Okay, let's talk about theoretical probability distribution class. So we've talked about the conditional probability last lecture na ko, no, nga ako na pong i-upload. And as I mentioned sa inyong class representative na may assignment sa conditional probability and then another assignment for this topic. So isahan na lang na ako sa last part ani nga lecture. Okay, so let's talk about theoretical probability distribution. Part ano is the binomial distribution, Poisson distribution, but right now we're just gonna focus on the binomial probability distribution. Okay, so let's first talk about some terminologies that we are going to be encountering sa itong topic. So we have variable. So the term variable is basically any characteristic that can be measured or categorized, such as weight, height, blood pressure, and so on. And then under a variable, we also have what we call this random variable. And the more we discuss probability distribution, mas ma-encounter tag term na random variable. It's just basically a variable, pero it has, ang iyang definition diri is that it can assume a number of different values such that any particular outcome is determined by chance. So basically, there is an element of chance sa imong variable, mo na imong random variable. For example, di ba ang variable diri is height, weight, blood pressure, and so on. So when you say random variable, example na is flipping a coin. Okay, ang random variable mo na is ang head or tail. Okay? So, there's an element of chance that is attached to it. Okay? Pwede man may compute ang chance that you're going to get head by flipping a coin. Diba? That is 50%. And then for tail, 50%. It's just the same with, for example, you roll a dice. Okay, so there's a random ang random variable nimo ana is ang outcome sa imong pag-roll sa die. So there are 6 outcomes, di ba? So meaning the chance per number is 1/6. So again, random variable ang naara siya attachment class sa chance. Pero under gyapon siya sa imong term nga variable. Okay, we have another term here, discrete random variable. Basically under siya sa imong random variable. Pero ang imong number of outcomes is finite or countable. And then, ang opposite ano is continuous, meaning it can take on any value nga within a specified interval or continuum. Okay, so I think mag-discuss ta ani after few lectures kining discrete ug continuous. So, ato ta karon class sa tawag nito probability distribution. So every random variable has a corresponding probability distribution. Ang kanang probability distribution is ang imuha ng um, basically mura siya histogram class atong gi-graph ang probability of each gitawag na tong outcome of success. Okay? So in discrete cases, it specifies all possible outcomes of this random variable along with the probability that each will occur. Okay, so mas mag-focus na lang sa discrete. Sa continuous, it allows us to determine the probabilities associated within specified ranges of values. Pero in this case, discrete lang sa ata para mas makita na to ang kumbaga beauty of probability distribution. Okay? So, example, we have this. Okay? So, this is table 7.1 sa atong book nga wala pa na ako rin sa gusto. Biostatistics ni siya nga book na. So, this sample table here is the probability distribution of a random variable x representing the birth order of children born in the United States. So, in comparison sa itong mga data nga na-encounter before class, di ba natin mga frequency? So, example, nagitagatag certain number of population and then atong i-categorize into a specific category. Okay? For example, age baka nila, and then how many people within aning age range, and so on. So we're computing frequency. And then we compute relative frequency para makita na to ang proportion ani nga certain event or certain category, no, with respect sa imong total number. Di ba mo man na tong probability, that's how we compute probability. So here's a probability distribution class. You're given kato na diretsong probability. So imagine lang nga nanani siya frequency distribution somewhere and then kita gana mo probability. Okay? So kaning yung first column here, which is X, this represents the birth order. So firstborn, secondborn, thirdborn, fourth, and so on. Okay? So pila daw ko na ang probability sa kaning certain population nga data nga firstborn child siya. So the probability of that is 0.416. So medyo high. Okay? So imagine na lang class sa US. Okay? Nag-pick ka og random person or random child ba? What is the probability daw of that your randomly chosen child is the firstborn sa iyang parents. Okay? And the answer to that is 0.416. So basically, kini nga data, gi-compute na niya siya based sa katong ilang nakuha nga nag-gather nila nga data class katong sa frequency, relative frequency, and so on. Okay? Gitagalan ta ani para ah dili na ta moagi atong mag-compute ta sa ilang probability para maka-graph ta sa iyang probability distribution. Okay? So, naatay okay, here class, so sa second, sorry, when the probability daw class, kaning x is equal to x. So, kaning big nga variable x. So, class. Okay, kining dako ang letter x diri. So, that's a general variable nimo, no? Random variable. And then x here, small letter, is katong order sa imuhang sa bata, no? Okay? And then, mo na din iyang probability. Alright, so when we graph that, ang atong x-axis will be the birth order x, and then y is the probability. So kung atong i-graph, the kung firstborn siya, ang probability daw is high, no? 0.416, so mo na nga value. It's basically just a histogram, di ba? Birth order second, so mo na yung 0.330, and so on. Okay? So this is the probability distribution of this table. Okay? So, unsa na to pag-relate na sa atong topic mo? Let's first have, okay. Gikan na to nga table class, unsa na to siya pag, what are the problems day nga atong i-solve? Basically, kung natin nga nga data. Kung natin probability distribution, napot tayo nga nga table, no? So, usually mga pangutana is, what is the probability that, for example, number 1, that a randomly chosen newborn is its mother's fourth child? So, kung magtanaw ko sa imong table, you're going to see, of course, you're going to have, kuan, you're going to see or check asa ang imong x is equal to 4, ana. Okay? And that will be this one. And then what will be the probability? That is 0.058. Okay, or 5.8%. So, kung pakutay ko, sa probability nga kung choose ka randomly o bata, kung sa probability nga ika-fourth na siya sa iyahang ika-fourth na siya nga child sa iyang parents or sa iyang mother. Okay, so the answer is 0.058. We can ani nga table. Okay, what if it's a little bit more complicated? So the second question here is, what is the probability that the infant is its mother's first or second child? So unsa tong na-learn before? When you have two mutually exclusive events class, na kini siya, these are mutually exclusive na naman, ang 2 o 4. Because if you're a second born, dili naman ka pwede mo fourth born or fourth child, di ba? In the same way nga kung ika-fourth ka, dili na ka pwede ma-second. So, they're mutually exclusive, and so we can just use the additive rule of probability. Okay? So, what is the probability, again, that the infant is its mother's first or second child? Lang, anong 4 o 2 man ni wala, zero na ko na i-listen. Ako i-listen na, pero 1 ni siya, kay mo man na kinabutang dila. Okay? Let me just change that. So, okay, first or second child. So basically, ito lang tanawon is kani. Okay? Again, they are mutually exclusive. So we can use the additive rule because they're again, dili man pwedeng firstborn ka o niya secondborn sad ka. Okay? So we just add the probability of being a firstborn child and then secondborn child. No? So the probability of that is 0.746. So ang idea ng class is you get the idea ba? Kung magkuha daw ka og random, mag-choose ka ba randomly sa population. Gikan ani nga population of data. What's the probability daw nga imong makuha or imong ma-choose nga infant is first or second child? Kung tanaw na to sa table, dako kaayo ang probability nga first child siya kay naabot siya 0.416, di ba? And sa second child 0.330. So imong kung tanawon, kung mag-pick day ko og random infant dira, ang probability nga first or second child siya is dako og samot, di ba? Kay sila gud ang highest sila gud ang highest probability. Okay, so it just makes sense nga ang imuhang probability of picking first or second child is 0.746. Okay, so I hope it makes sense. Okay, number 3, what is now the probability that the infant is its mother's third and above third child? Okay, so same na gyapon ang idea, class. Mother's third and above third child. So imong tan-aw ng probability na third born siya, i-add nimo dito sa probability nga fourth, fifth, and so on. So basically greater than 3. So inanaw na to ang notation ni P. Okay, instead of x is equal to 3, so pwede ta maggamit og greater equal to 3. Basically, you're getting the probability of x is equal to 3 plus probability of x is equal to 4 and so on until sa imong last nga 8 plus, naka 8 plus siya. Okay, so pwede sad nga because ang total sa imong probability man gid ani class in one data no kay 1 man gyud. Okay, think of this as one whole sample space where all the probability niya is going to be equal to 1. Okay, so meaning kung ano na ako ang probability sa x greater than 3, pareha na if ang 1 i-minus na ako sa probability of x less than 3. Correct? Complement niya ba? Okay? So nga naman kay nakuha na mo nato diri class ang x less than 3. Kay 1 ug 2, kung ato nang i-add mo na siya ang probability sa x less than 3 kay dili man included ang 3. Ang probability x greater equal to 3 diri na na-include nato ang 3. Okay? Ang kini siya x less than 3 values nga x kay less than 3 or 1 and 2 only. So basically, kanina nga value. Nga nakuha na to sa previous number. Okay? So 1 minus, kani siya sum sa duha. Okay? Naka-minus na nga kay naka-distribute ang negative. So that is 1 minus 0.746 or that is 0.254. For this side, if i-plus mo from 3 to 8, mo ni mo makuha nga value class. It's just the same answer. Okay, so that's one example of probability distribution. Now let's go to a more specific distribution. We call this the binomial distribution. So from the word binomial, duha. Okay, so this is a probability distribution that describes the number of successes in a fixed number of independent trials, where each trial has the same probability of success. And mas makita na to sa example later class. Pero basically, kining model class is a situation where there are only two possible outcomes. Okay, with the success, with the failure, yes or no, heads or tails. Basically, if you're given a problem where there are two possible outcomes, you can create your binomial distribution. You can use ang imong formula for binomial distribution. All right, so natin mga key assumptions for class for binomial distribution. Pero let's have an example lang para lang makuha ninyo, imagine na sa ninyo. So suppose this data from 1987 daw sa United States gyapon. They found out that 29% of the adults smoke cigarettes, cigars, or pipes. Okay? But it doesn't matter kung saan yung smoke. Basta kay smoke siya. So, i-describe po sa problem class that the outcomes are mutually exclusive. So, only smoker and non-smoker. So, di mo ka pwede smoker at the same time non-smoker. So, isa lang yun. Okay? And then exhaustive. Exhaustive in the sense that the-emphasize niya nga exhaustive. If you remember sa previous lecture, exhaustive means that the probability, the sum of the probability is 1. Okay? Now, kinilang two outcomes, aside from the fact that they're mutually exclusive, they're also exhaustive, meaning their probability sa duha is equal to 1. Meaning, sila lagi ang duha ang outcome. Okay? Kaya kung dili na siya equal to 1 in probability class, there must be another probability somewhere there. sa imong sample space. Okay? So it's very important to emphasize nga exhaustive ni siya nga data or outcome. Excuse me. Okay, so let's represent a certain variable y sa atong smoking status. Okay? So y is equal to 1, pwede ta mag-assume, pwede gani y is equal to 0 mo itong smoker. Pero in this case, 1 na lang ta, okay? Y is equal to 1 mo na itong smoker. And then y is equal to 0 mo na itong non-smoker. So if we get the probability of y is equal to 1, that is the probability nga smoker ang adult. Kato from the data that we have no in 1987. So, ningo siya dili 29%. So basically mo na imong probability. Mo na yung proportion nimo sa smokers with respect sa total population. So the probability na will be 0.29%. Sorry, 0.29 or 29%. So what is now the probability of y is equal to 0? Meaning, dili siya smoker. So all you have to do, because exhaustive mo na yung mga outcomes, pwede na ito ma-apply ang ato ang na-learn nung 1 minus katong imuhang probability sa smoker. Because sila naman duha ang outcome. So 1 minus 0.29, that is 0.71. Meaning 71% of the adults are non-smoker. Okay? Actually, hindi na kailangan mo i-analyze, no? Makabulan na nga, if 29% of the adults are smokers, then the rest will be non-smoker, which is 71% of the adults. Okay? So, let me just edit. Okay. So, okay na dito. Okay. So, muna akong i-mention ganina, there are key properties or assumptions for binomial distribution. Number 1, there are fixed number of trials and n class are repeated trials, meaning there's an assumption nga wala kay baguhon sa imong next trial or wala kay laing factor nga i-include ba. They are similar and they are consistent ng mga trials. Okay? And then it is repeated. And then next assumption is the outcomes of the end trials are independent, meaning ang next nimo nga outcome, sorry, sa imong next trial, the outcome will not be affected by the first outcome sa imong first trial. Okay, mo na ang gingon na to nga independent to. Dili ma-affect ang outcome sa isa ka event dito sa other event. And then the third assumption is that the probability of success P is constant for each trial, meaning ang probability of a certain outcome sa imong first trial plus dili na siya mabag-o sa imong second trial. Okay? Ang pinaka-nito nga example ani is flipping a coin. For example, you flip a coin 3 times. Okay, so ang n nato diri class will be 3 because that's the number of trials or that's the number of times we flip the coin. And then, ang atong probability class, for example, ang ato ang i-assume nga success, no, quote-unquote success, is getting ahead sa imong coin. Okay, so when you flip your coin, getting ahead, ang probability na will be 50%, diba? Because 50-50, duha naman yung mga possible outcome, head or tail. Okay, so constant ra siya. Ang second assumption diri nga independent siya because kung mag-flip ka sa second time, kung nakakuha kag head sa imong first nga trial, 50% man yung probability, di ba? Dili man ma-affect ang imong probability of getting ahead sa imong second flip. Dili man siya mayamong 90% just because you get ahead sa imong first flip, di ba? So, independent siya, at the same time, constant ang imong probability of success. So, those are the key assumptions of a binomial distribution. So, let's have a more in-depth example. Before we have example this is now your formula for getting the probability of the number of success. So, lahi na siya sa imong probability of getting ahead, no? So, for example, class, balik ta sa itong example lang. For example, we get 3 times, siya po natin i-flip ang coin. So, n will be 3, okay? And p here, because we assume getting ahead as the success, ang atong p here will be 0.5 or 50%. So, ang isulatan na ako, wala ko pen, pero hopefully, natarong na ako. Okay, 50%. So, muna itong example ng heads or tails. So, itong n class is, suppose no, 3 times na ito lang siya i-flip. Right, 50%. Kaning x, din sa pasabot ani, the number of success basically class, kung nag-flip tag 3 times sa tong coin, gusto ta makabalo sa probability distribution niya. How do we get that? We analyze or we solve for the probability nga sulod sa n trials, which is 3 times, pila daw ang probability nga wala kay makuha nga head. Okay? 0. Ang naka-0. Karon, mag-solve po ta pila ang probability nga isa ra mo makuha nga head sa 3 nimo ka times gi-flip ang coin. Pila po ang probability nga duha imo makuha nga head. Pila sa ang probability nga tulog yun ang imo makuha nga head. Okay? So, meaning, ang ato din probability distribution is not the probability itself of getting the outcome, but rather the number of success x, no, in n repeated trials. So, I hope na nag-guess niyo, no? So, in this formula, we have here P of x is equal to x, wherein mo number of success, okay, is equal to n x. Actually, this is your combination ng formula sa tanawagan ni class. This is n factorial over x factorial times n minus x factorial. So basically, gikuha na tong combination dire. Okay. And then, multiplied by p, that is now the probability, no? Ang nanala ninyo, small p class is the probability of getting ahead sa imuhang pag-flip sa coin. So, each trial, what is now the probability of getting ahead? That is just 50%. Okay? And x na to diri is katong whatever ang tong i-value dira. For example, 0. Of course, 0 po ni diri, 0 po ni diri. Okay? And then times 1 minus p. Actually, 1 minus p here, 50% lang gihapon ni, no? Natin may example nga dili 50% para mas ma-emphasize siya class. Pero basically, kining 1 minus p is the probability of failure. Meaning, imong fail, imong nakuha. Okay? Raised to n minus x, and that is the number of trials minus x. Katong imong value dira. Okay? So, n minus x also represents the number of failure. Alright, so kung atong i-solve class, wala ko pen. Ako na lang yung ipa-class. Give me some few minutes to set up. Alright, so nag-assume ta nga 3 siya ang ato pag-flip, no, we are flipping a coin. Flip a coin 3 times. And we want to see and compute the probability of getting ahead. Ato na lang siya i-tabulate class. So we have here x. And then we have here the probability na dayan of x is equal to x. Dako ni siya nga x. Okay. So, kung natay 3 times less or n is equal to 3, natay 4 dre ka row. Apilan mo na tong 0. Again, we consider 0 kay we want to see the probability man of getting 0 head sa 3 times ni mga pag-flip, or once makakuha kag isa ka head, twice, and then 3 times makakuha kag head. So apil nimo ang always ang 0. Parehas ato. Wala pa din. Sa tong next example na to. Okay, so the probability of getting no head class sa 3 times mga pag-flip is basically p times x is equal to 0 na dira is equal to 3. Yeah, 0 dira, that is combination of times probability of getting ahead. Kining p is the probability of success, no? So head is 0.5 raised to 0 times 1 minus 0.5, basically 0.5 bigapon. Nya kani is 3. Okay? So, unsa may value ni mo ana? We just solve that. So, pwede na ni mo i-shortcut sa combination class. Nga, Kung sa mong calculate. Okay, so we have 1/8 or 0.125. Okay, pila po na probability of getting daw isa ka head sa 3 trials nimo no. So ato gyud po na ilisan karon ang x nimo og 1 na class. So this will be 3 nya 1 na ni. Then kana 0.5 nya 1 na din na siya. 1 minus 0.5, this is gonna be 2 na dayon. Okay, ang tan-aw lang ninyo class, mag-total na imong exponent of 3. Kay mo na imong n. Okay? Kini siya kung mawanan ni mo exponent dira 2 na lang na. So 3 gyapon niyang total, di ba? So make sure nga ilisan pud na nimo. And that will be 3/8 or 0.375. Okay. Ako na lang diretsuhan. I think this is 0.375 and then this will be 0.125. Okay? So, ato nang buhatan og probability distribution later class. Pero let's have another example first. Okay, before we go to the next example, ato sang i-analyze ang mga value diri class. The values are 0.125, 0.375, 0.375, and 0.125. Ang pasabutaan ni class is when you flip your coin 3 times, there's a higher chance daw because kini nga value 0.375 o 0.375. Dako ang chance na sa pag-flip nimo 3 times sa imong coin, you will get 1 or 2 heads. Okay, mo na siya pasabot kay 1 and 2, the number of success man sa 1 and 2, no, they have the highest probability. Alright? Sige, let's have another example. I'll just read. Okay, suppose we have 3 white balls and 2 green balls in a bag. So, dili siya iyan straightforward no nga ingon ba nga heads or tails, okay, success or failure, yes or no. So, sometimes it's phrased, the question or the problem is phrased this way na medyo tricky, okay? So, we have 3 white balls and 2 green balls in a bag. Pero, tan-awon mo class, this can be an example of binomial distribution. You know man, because you only have 2 outcomes, white or green. Okay? Siguro na-trick lang mo sa number of white balls and number of green balls. Pero basically, you just have 2 possible outcomes. Okay? White or green. Okay? So, we take a ball from the bag at a time and then put it back in the bag. So basically, nagkuha kag bag, nagkuha kag ball from the bag and then gibalik nimo, then kuha na pod gibalik na pod nimo. Okay? So, suppose that we want to take a green ball, denoted success. So ang atong goal is to get a green ball. And then the number of trials daw class is equal to 4, meaning kaupat ta magkuha og ball. Okay? First trial. Okay, first trial. Unsa nga color? Ibalik na po nato ang ball. And then second trial, ibalik na sa nato. Third, and then finally, fourth trial. Ang atong i-calculate karon is the probability of success. Pila daw ang probability of getting 0 or wala jud kay makuha ang green ball sa total ni mga 4 trials. Pila ang probability nga isa ka green ball imong makuha? Pila probability nga tulo? Pila probability, 2, 3, and 4. Okay? So, tan-aw lang ta class ni haom siya sa ato ang assumption sa binomial distribution because it has 2 outcomes only, white and green. The outcomes are independent, nga naman. Kay kung ibalik na ako karon akong nakuha nga first ball class, dili man ma-affect ang ako ang probability karon sa second nga nako nga trial kay gibalik man ako dito ang ball, di ba? Wala may nausab sa ako ang condition. Okay, next is ang outcome will be the probability of the success is going to be the same nga naman. The probability P of which is this is taking a green ball class is 2/5 nga naman. There are 2 green balls. Okay, the number of occurrence nila 2 divided by 5. Kay mo man ang total ni mga balls sa sulod sa imong bag. So, therefore, the probability of taking a green ball is 2/5, 0.4. Right? So, nanatay P karon. Ang ako lang sulat diri balik ang formula sa binomial distribution class. That is nx man na and then p raised to x and then 1 minus p raised to n minus x. Okay? So karon dapat unahon nato kuha ang kining gamay nga p which is 0.4. Muna ni pirmi man atong kuan. the probability of getting a green ball. Okay, let's solve the probability of success. X is equal to 0, meaning sa 4 trials, wala nyo kayo makuha ang green ball. Bilang probability, ana? So, i-substitute mo dila ng class, you get 0.1296. So, nakita niyo pattern. Dili ra kayo, no? 0.4, of course, mo na mong success, mo na mong failure, 0.6. This is actually the probability of getting the white ball. Okay? Okay, kung i-sum na nimong duha, that is equal to 1. And then, kung makita ninyo yung pattern po, again, kini siya, mga exponent, well, you'll have a sum of 4, which is the number of trials. 3140. Alright, so, muna yung itong masolve class, x is equal to 1, yung probability of success is 0.3456, and then for 2, 0.3456, 0.1536 for x is equal to 3, and then 0.0256 for x is equal to 4. So, graphing that or making kind of a binomial distribution or probability distribution for that, again, ang imong y-axis will be your probability, and then your x-axis will be your katong imong number of success. Okay, so 0, 1, 2, 3, 4. Again, kung nakay n repeated trials class, n plus 1 you ka always no sa imong x because you're gonna include 0. Okay, so if you graph that, you have 0.1296 kani, 0.3456, 0.3456, 0.1536, and 0.0256. So this is your binomial distribution. Alright, so actually na siya shortcut class, no? Gitabulate na ni siya. Okay, magbalik-balik ba na siya? Lahat lang siguro problem, pero if you have the same number of n, the same number, the same probability, you will always have the same binomial distribution. So, naka-table na ni siya. So, in this specific book, ang yan table, ano na sa Appendix A, Table A.1. Pero you can search sa internet, kining binomial probabilities. So, nakatabulate na siya for selected values of n and p. So, kini siya nga screenshot is from the book Biostatistics, no? So, ang n mo will be the number of trials, basically. Ito sa imong first column, kining siya. Dili na ko makuha tanan ang table, kay gamay naman siya, gamay, di niyo maklaro. So, nagkuha lang ko dire from 2 to 5. So, kani siya is from n lang siya less than or equal to 20. Kay if mo greater than 20 mo siya class, your values will be very, very small. Nga dili na siya, wala na siya effect bitaw. And that will be modeled in the Poisson distribution ako. So that will be our next lesson. Pero here lang sa binomial, mag-focus na ta when your n is less than or equal to 20. Alright. And then your k, mo yung first column na kaning n here. Kini siya, mo yung first column. Meaning this is the number of trials. So nakita niyo class. Sa imong second column which is k, that is the number of success. Kung 2 siya, 3 imong k. Kay maapilan 0. Kung 3 siya, 4 ang imong k. Ante, ma-increase yun siya og isa. Okay? And then your p is the probability nga mga values nasa imuhang row, first row. Okay? 0.05, 0.1. And sa itong specific example class, we have an n is equal to 4. Okay, pangitaw na to karon sa table kung sa itong na-solve. You have x is equal to ang 4 basta kung naka-identify na ka 4, okay nakadiri nga row, no? So, sakto ni we have 5 nga na-solve, no? 5 ka probability. And then, what is the probability of getting a green ball? Mo ito yung 0.4. So, diri ni mo siya tanaw, 0.4. Okay? So, ato na din na siyang itanaw na ang iyaha ang intersection class. So, 0.4, dayon, n is equal to 4. This will be the answer. Okay, 0.1296, 0.3456, and so on. So, same siya sa ato ang na-solve diri. Alright. Okay, so ingana na siya. So, naa pa yung table nga mas comprehensive pag yan class, mas gaan pag siya og value sa imong probability or in between nga mga values ba. Kaya di man gud mo ma-capture ta ng value. Pero, mo na ni siya ang pinaka basic nga binomial probability table. Okay, so I will show you before we go to the next one. Na din tayo kuan class para dali ninyo makita. Natay kuan diri ka ng Kini siya binomial distribution. So, for example, sa ato ang gisuot ko ganina nga n is equal to 4, n is equal to 4 niya. P na to is 0.4. Mamantong probability of getting a green ball, no? So, mo-graph na din na siya sa iyang binomial or probability distribution. Okay? So, pwede ka magbutang dira og unsa nga value para ma-highlight to niya nga bar. Kana. But, pwede sa mo siya i-hover. Right? So, kung gusto lang ka o kung gusto nimo makita ang probability distribution sa specific nga data nga imong nakuha ba, kay ang table man good, table na siya, table of values na siya, pero dili nimo makita ang iyang unsa itsura sa iyang probability distribution. Okay? So, pwede siguro na ko ni-add kung gusto mo or pwede na nyo pa nitaon sa ending book. So, next will be, okay. So, let's go to the features sa iyang shape sa imong binomial distribution. So, number one, it is unimodal. So, na-introduce na ko na sa previous few lectures ago, no? Sa unimodal, isa ra imong mode. Makita nimo sa graph, kay makita nimo nga isa ra iyang peak. Di ba natin graph class ngayon ni? Ay, pag-pen. Okay. Di ba nato yung graph ngayon ni? Muna siya bimodal. When you say unimodal, yung na siya. Okay? Kay later, mo na to ang foundation good sa pag-graph na to sa normal distribution. Okay? So, again, for unimodal, it means that it has a single peak. Alright. Now, P is, kung P daw class is less than 0.5, the distribution is skewed to the right. So, itong skewed to the right, if you have mo mong normal distribution and introduce naman ko na siya, ang imong skewed to the right will be na siya slant, diri siya padulangan natin. Ano ba? Sa right, medyo dito siya nag-slant. Okay, kung P daw is greater than 0.5, ang distribution namin is skewed to the left. So, nakaana siya. Na. And then, kung 0.5 siya exactly, the distribution is symmetric. So, nakita niyo siya itong previous example class. Ato sa 0.5, gamay na mo kay dili na kay nato siya ma-appreciate, no? Katong flipping a coin ba? Ato na lang siya i-graphs. Mag-increase tag number of n class para mas makita nato ang iyang kasymmetric. Pero masking gamay imong number of n, makita man nimo sa mga values kung ga-mirror siya sa each other yung mga values. So, for example, you have n is equal to 4 lang gyapon, pero let's have 0.5 as value sa imong p. So, grabe siya ka symmetric, no? Nasa isa dira 0.375, and then you will have the same values sa imong x is equal to x is equal to 3. Nya kana din siya, tungod ra siya. Okay? So, next example nato is kani 0.4 nga n is equal to 4. So, nakita ninyo, medyo skewed siya sa imuhang right, di ba? Murag nagtipok ang iyang dagko nga values dito sa imong left. So, mo na imuhang feature sa imuhang probability distribution when your probability is less than 0.5. So, butang na itong 0.3 pagid class. Kung sa kaya itsura niya. Okay? So, nakapagyapon rin tipok. So, mas slant na pagid siya dira. Kung 0.2, okay. So, nakita ninyo, magkagamay ang probability, magka-skew siya sa imong right. Mas magtipok ang imong dako nga values ito sa imong left. Okay, next would be greater than 0.5. So, try na to 0.6 ni. Dili na po siya nagtipok, di ba? Sa right. Na-skew siya sa left. Kung 0.7, samot. Okay, 0.8. Okay. Hantod sa murag imong 0 kay 0 na gyud siya value and probability of getting 0 success is almost 0 na gyud. So the more you increase class, the more na siya mo skew. Okay, let's have another example here. Before that, mga graph na to. Sa atong graph class, di ba, oh yeah, we are going to solve mean, variance, and standard deviation. Pero we cannot get directly gikan sa imuhang data nga given nga gihatag, no, because ang given sa to diri is the value of probability na diretso, wala tagitag frequency, wala tagitag pila ka buok ang total population and so on. So Anad man ta mag-solve og mean standard deviation variance gikan sa ato ang values gyud sa population. Pero in this case, kung wala tayong population, given the probability, how are we going to solve the standard deviation, mean, and variance? So, makuha na nato siya class from the values of our n and p. Okay? So, mean here will be n times n. Standard variance din naka-s squared is n times p times 1 minus p. And then, i-square it lang nimo, you will get standard deviation. So, if you solve the mean variance and standard deviation of our previous example, which is n is equal to 4, yeah, p nimo is 0.4. So, your mean will be 4 times 0.4. And that is 1.6. Okay? Actually, class, makuha lang nimo diri ay kung ato na butang na siya here. Okay? Ang mean niya is um wala pa lang na ako na-introduce pero there's also another notation class. So, for population, kini siya for sample, for population, mo ni siya ang ihang kuan, mu, ang ihang notation. And then, this one will be naka sigma squared na kana siya kay sigma. Pero they're just the same. Okay. 1.6 na siya diri. And then, you have s squared is 4 times 0.4 times 0.6. Okay, that is 0.98. Okay, nanana siya sa ubos tanan. 0.96 there, 0.96. And then getting the square root of s squared or 0.96, that is 0.98. Okay. All right, so let's move on to some examples at ang graph. Okay, this one class is a probability distribution of some binomial random variable for n is equal to 10. Okay, and then p is equal to 0.9. So, pwede na ito input na po dire. N is equal to 10, and then imong p is 0.29. Okay, so nga na siya gitsura. And this is the number of smokers na yapon eh. Okay? So, makita ninyo nga, skewed siya sa right. No? Kay tungod, ang imong value sa probability is 0.29, less than 0.5. And then, solving for the mean variance and standard deviation, na siya dira sa ubos. Okay, this one is an example of a probability distribution na skewed to the left. Your value for P is 0.71 and then N is 10. So, atong try 0.71. Actually, opposite rin sila sa 29. Right? So, that is skewed to the left. And these are the values of mean, variance, and standard deviation. Okay, so mao po niya nga to ang probability distribution for a random variable nga probability nimo kay 0.5. Okay, so kato, kung exactly 0.5 siya, symmetrical ra siya. Okay. Okay, so I think that's the end of the discussion for binomial distribution. We'll go to Poisson distribution next lecture, but first, I'll give you this assignment. This is supposed to be, again, the seat work for conditional probability. And then this one is for this topic, binomial distribution. So this one, all you have to do, class, is solve for the probability that a randomly chosen individual prefers T given that they fall within the age bracket of 31 to 50. So you can use the Bayes theorem or katong conditional probability yun nga formula. So either way, you will get the same answer, ma'am. And then this part here, aside from calculating the probability of getting exactly whatever is asked there per number, you have to make a probability distribution for each problem. Therefore, dili lang katong gi-ask sa inyo nga inyong paon, kundi katong tanang probability of successes from 0 to n number of trials. Okay? So basically, solve for the probability of successes and then make a probability distribution for each problem. Okay, so that's the end of binomial distribution. Reminder, they should be submitted on Thursday, 3 p.m. So you can submit before that deadline. Okay, so thank you for listening and see you in the next lecture.